video is about average rate of change. We'll talk about what it is and how you find it from a graph or a table of values. Let's get started. The definition of average rate of change is given a function f whose domain contains the interval of real numbers a to b and including a and b, and whose range is a subset of the real numbers. The average rate of change on the interval a to b inclusive, meaning including a and b, is defined by the number f of b minus f of a over b minus a. Okay? Although you may not see it yet, this should remind you of an equation that we used a lot in Algebra 1, y2 minus y1 over x2 minus x1. That's the slope formula. Okay? Now, the slope formula is helpful for straight lines because the slope doesn't change. Average rate of change helps us find kind of the slope in an interval on a curve. Okay, let's look at this example. They're about oil well production in Glenpool, Oklahoma. Okay, and this is the number of oil barrels per year that were produced. Okay, between 1910 and 1916. Okay, and we'll find the average rate of change in different intervals. So let's start off by looking at it between 1910 and 1916. That's all the data we have there. Okay, we'll look at, let's see here, just following the formula, the function value at the last x value, 1916, minus the one at the very beginning of the interval, 1910, divided by 1916 minus 1910. Okay, now in 1916, we're just going to estimate here that number might be about 350-ish. Okay, let's say 350. In 1910, I'm going to estimate as about 3,400 divided by 6 years, and I get negative 508.3 repeating barrels of oil per year. Now, what does that mean? That means that on average, between 1910 and 1916, they're producing, on average, 508.3 fewer barrels per year. That's what that means, okay? Now, that's also, what that really is talking about is the slope of this line. If I drew a straight line from one end of the interval to the other end, what's the slope of that line, okay? And that just tells you the average rate of change within that interval. So it's a way of talking about slope on an interval in a curve, okay? Let's change the interval. So between 1910 and 1913, I'm looking kind of at this interval right here. Okay, I use the exact same formula. So let me go over here. I have the function value at 1913 minus the function value at 1910 divided by 1913 minus 1910. Okay, at 1913, it looks like the value was about, let's say, 800. I'm just estimating here. So I have 800 minus, in 1910, we thought it was about 3,400, divided by the 3 years in that interval, and we get negative 866.6 repeating barrels of oil per year. And what that means is that on average, between 1910 and 1913, the average rate of change, the average, decline is 866.6 barrels per year. Okay, that's also the slope of the line connecting those 2 points in that interval. Next, we'll look at the average rate of change on the interval from 1913 to 1916. So again, it's the function value at the end, 1916, minus the function value at the very beginning, 1913, divided by the x values, 1916 minus 1913. Okay, in 1916, we thought that it was about 350 barrels of oil per year. And then in 1913, it was about 800 barrels of oil per year, divided by 3, because there's 3 years in that interval, and it's about negative 150 barrels of oil per year. Okay? So that is the slope of this line. Okay? Or it's the average rate of change within that interval. Okay? So again, it's a way of thinking about slope of a curve, and you're looking within an interval, what is the average change within that interval? Okay, the following table lists the number of hybrid electric vehicles, HEVs, sold in the US between 1999 and 2013. Calculate the average rate of change of the number of HEVs sold on the interval 2003 until 2008 and explain what that number represents. Okay, so this is the average rate of change from a table instead of from a graph. Okay, we still do the same thing. We look at the function value at the end, 2008, minus the function value at the very beginning, divided by the difference between the x values. Okay, this is pretty easy. Just look at the table. So 2008 is this number, this 312,386, minus 2003, which is 47,600, divided by, there's 5 years in that span. And so to compute, we get 52,957.2 HEVs. Now what that number means is, on average, between 2003 and 2008, 52,957 more HEVs are sold per year than the previous year. Okay, so again, it's like the slope between those 2 points on this, curved function. Okay, now let's look at some other problems from previous released Park questions about average rate of change. Okay, these are in no particular order. I order them based on the number value in that test. So suppose a weight is attached to a hanging spring. When the weight is pulled down and released, it will bob up and down with vertical displacement from its original resting point. The graph shows a weight pulled down 3 centimeters and allowed to go up and down for 2 seconds. Okay, so it goes woo, goes up and then down. Okay, what's the average rate of change from point P up here? Let's change the color so you can see it a bit better. From point P up here to point Q. Okay, well, it's an average rate of change. So I look at the function value, the y value at the ending point, that's point Q, minus, and I'll just kind of fill that in now actually. At Q, it's 1.5. Minus the function value at the very beginning of the interval that I'm looking at, 1, divided by 1.5 minus 1. Okay, now the function value, the y value at 1.5 is 0. Okay, this right here, the y coordinate is 0, minus the function value right here, the y coordinate is 3. I'm just looking off the y-axis there. Divided by 1.5 minus 1 is 0.5. 0 minus 3 is negative 3, divided by 0.5, and you get negative 6. Okay, and as far as units, I'm not sure if they're asking for units here, but it'd be negative 6 in the context, centimeters per second. Okay, now it doesn't actually, so you're looking at, in that interval, the average rate of change, the average speed for that spring in that interval would be negative 6 centimeters per second. Okay, so next, Laura is jumping rope for exercise. The function h of t, negative 2 cosine 2 pi t plus 2, gives the height of the midpoint of the rope. So the very middle of the rope where it's kind of going up and down, that's what it looks like on the graph. So it's just going up and then down, jumping rope. Okay, the graph of the function is given for the time interval 0 to 2 seconds. Select all the intervals over which there is a negative average rate of change. We're looking for basically a negative slope between those 2 points. Okay, so between 0 and 0.5, it's going to be a positive slope, not negative. Between 0 and 1, It's going to be a zero slope, not negative. Between 0.5 and 1, that is negative. Okay, that's it. Okay, but it's that's all that applies. So let's keep going. Between 1 and 2, it's a slope of 0, so it's not negative. Okay, so it's thinking about slope on a curve is how I think about it. Okay, number 17. The graph represents the height in inches of a boy from age 5 to age 20. Okay, now first of all, looking at this graph, I don't actually believe this is real data because most boys that I know have their growth spurt between 10 and 15 years old. I don't know a lot of boys that have a growth spurt. I mean, there are some, right? But as far on average, most boys don't have a growth spurt between 15 and 20. Here we go. So select the correct number and phrase to complete the statements. Between the ages of 5 and 20, the boy's height increased at an average of blank inches per year. Okay, so my interval is from 5 to 20. So the function value at the end minus the function value at the beginning divided by 20 minus 5. The function value at the end is about 75. Okay, minus the function value at the beginning is about 45. Divided by 20 minus 5 is 15. And so 75 minus 45 is 30. Divided by 15, you get 2 inches per year. So on average, between ages of 5 and 20, according to this data, boys are growing 2 inches per year on average. Okay, the fastest increase, change colors here. The fastest increase in height occurred, now according to this graph, the fastest increase happened here where the slope is the steepest, so it's between the ages 15 and age 20. The graph models the height h above the ground in feet at time t in seconds of a person swinging on a swing. Each point indicated on the graph represents the height of the person above the ground at the end of each 1 second interval. Okay, so the person swinging back and forth, and that's their height. Okay, select the 2 time intervals for which the average rate of change in the height of the person is approximately negative 1/2 feet per second. So we're looking for at which interval would we have an average rate of change of about negative 1/2. Okay, from 0 to 1, that is positive, not negative. Oops, not negative 1/2. Okay. From 1 to 2, it is negative, but that slope is like a negative 2. Like I'm running 1 and dropping about more than 2. So it's not 1/2. Okay. From 1 to 2 to 3, it's positive, not negative 1/2. From 3 to 4, so I'm running 1, so the slope, I'm running 1, I'm dropping about 1/2. That looks good. Okay. From 4 to 5, again, I'm running 1 and dropping about 1/2. So that's also about a slope of 1/2. Okay. From 5 to 6, it's positive, not negative 1/2. From 6 to 7, the slope is like a negative 2-ish. Okay. From 7 to 8, it's positive. Okay, so it's just in those 2 intervals do we get an average rate of change or a slope between those 2 points of about negative 1/2. All right, this video is about average rate of change. Thank you so much for watching.